If you are multiplying two numbers with the same base, you add the exponents. So that's like saying x squared times x cubed is x to the fifth. And the reasoning for that is x squared is x times x cubed is x times x times x, and then you have 5 of them in total. So that's adding. If you are dividing two numbers with the same base, you subtract the exponents. That would be like saying y to the fifth over y to the second is y to the third. You're subtracting because the top would have y, 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 y. Sounds like I'm talking about the world. Y, 5 y's over y, y. 2 of those y's would cancel, and you'd have y cubed left on the top. This one is called the power of the product. It's just a reminder that if you're taking a product or two factors to a power, you have to give the power to both of the factors. We have a similar thought with fractions. If you take a fraction to a power, both the numerator and the denominator get that power. So, for example, here, if you have 2 over x to the third power, you'd have to take 2 to the third power and x to the third power. So you get 8 over x cubed. So when you're taking a fraction to a power, just don't forget both the numerator and the denominator get that power. And then for number 5, Charlie said to use number 5 for the 10th entry problem, which was power of a power. Power, you multiply the powers. So for example, x to the 4th squared is going to be x to the 8th. Because x to the 4th squared is x to the 4th times x to the 4th. X to the 4th times x to the 4th, you would add 4 plus 4, and you get 8. This one, number 3, would be like 3x to the squared is 3 squared x squared, or 9x squared. That's a demonstration of the power of the product rule. Questions? All right, let's apply some of these now. So notice for number 1, both of these have the same base. They both have a base of 49, and they're being divided. So DJ, if they're being divided, what do we do with the exponents?
We subtract them.
Yeah, and so what do I get if I subtract 7 halves and 3 halves?
4 halves.
4 halves.
Or
just 2. And so you can leave your answer as 49 squared, or you could calculate it. My general rule is if I can't do it in my head, or if it gets way bigger by doing it, I just leave it alone. All right, next, you are multiplying two numbers with the same base. For the 5 halves and 4 to the -1 powers. Brendan M., what do we do if you multiply two numbers with the same base?
You take it, so it would be 16 and over 2, right?
All right. So you're multiplying two numbers with the same base.
Yes.
Like here, we multiply two numbers with the same
Oh,
base.
it's 4, my bad.
4 to the what?
4 to 1, or 2 over 1.
So did you add these? How did you get 2 over 1?
So you do 4 or 5 minus -1.
5 halves?
Yeah.
Plus -1?
Yeah. Yeah, 5 halves.
So we get 4 to the 3 halves. Okay, because we have to add 5 halves minus 1 or plus -1. That's 5 halves plus -2 halves. You have to get a common denominator.
wait,
Yeah.
why would we need 4? Like, because even if you square it, what do you do with the 5 then?
Okay, that's a good question. So if we have, let's say, 2 squared times 2 to the 1. Meg. 2 squared times 2 to the 1. Would that be 4 to the third or 2 to the third? So you have 2 2's right here times 1 2.
Oh,
So that's why it stays a 2, because these are, if you multiply them all out, it's just 2 2 and then 2. Same thing with the 4's. Isaac, can I simplify 4 to the 3/2 power? How could I write this with radicals? Radical 4 to the third. And can we simplify that? 2 to the third, which is 8. Good. So notice we started with things that, yeah, we could probably do it from the beginning too. But either way, we get 4 to the 3/2 power. That's the square root of 3, 4 to the third, and then you can simplify. Okay, dig in. This should be 64 to what power if you evaluate it? Well, I would first do the exponent rule, power over power. What do we do with these? That would be if you, okay, what do we get? Uh, 64 to the 1/2. And then, if you wouldn't mind writing that as a radical. Okay, and what do we get? 8. Good.
can you explain why you have one?
What do you get when you multiply 1/4 times 2?
Only because you have to put the one under the 2.
Yeah. Good question. All right, let's look at D. Okay. So actually, what would you want to do first with D? Do you want to square everything, or would you rather divide them? Okay. If you square the top and the bottom, what do you get?
Or just be x because
Good. So she multiplied this by 2 and this by 2 because she had to do power over power. When you do it of a fraction, you do it of the numerator and the denominator. And then what do you got?
x and 9.
Good job. If you would have divided first, you would have gotten the same answer, but you would have had to have fractions a little bit longer. So that was a benefit of squaring everything first. Yes?
First, you do 64 and 1/2. So why do you do the square root of 64 over 1/2?
What does the 1/2 power also mean?
Oh, wait, I got it.
Yeah, so we learned on Friday that taking a number to the 1/2 power is the same as taking the square root of that number. Oh, so we have a little surface area problem. So if we had a cube, considering the surface area, it's the area of all of the faces of the cube. So the top, the squares that make up the cube, if you found the area of all the squares and added them up, you'd have the total surface area of the cube. Do you know how many squares make up a cube? If you consider all the sides. 6. Yeah. So this is the area, surface area of a cube as it relates to the volume of a cube. Volume is how much space is taken up on the inside. So it tells you a formula relating the two together. Notice the 6 is there. That's because there are 6 squares that make up the cube. So it says find the surface area and volume of the cube if one of the sides is 5. And there's that formula. Really? Okay,
Well, would you do it 5 cubed?
5 cubed, good. 5 cubed is the volume. Because the volume of any rectangular solid, so that's any box at all that's a normal box, like box shape, you have length times width times height. And for this, all of them are 5 because it's all in perfect proportion. They're all the same. So the volume is 5 cubed, so it's 125 cubic centimeters. Because the centimeter gets cubed right along with the length. So it's 5 centimeters cubed times 5 centimeters, 5 centimeter times 5 centimeter times 5 centimeter, 5 times 5 times 5 is 125. We have centimeters times centimeters times centimeters. That's why it's centimeters cubed. So if you've ever been to the hospital and they've given you 125 cc's of something, ever heard that when you listen to medical shows or been to the doctor? A cc is a cubic centimeter. That's what that is. So now I can find the surface area, if I want, by either adding up all the sides or I can fill it into the formula. So the area of the surface is 6 times 125 to the 2/3 power. Who can rewrite 125 to the 2/3 in radical form? Denise?
You do radical. And then the 3. And then 125.
Then we'll square it. We can simplify, because what's the cube root of 125? 5. So it's 6 times 5 squared, 6 times. So we could do that, or you could just know that the area of any of these faces, like this face, the one closest to us, the area of that is 25 centimeters squared. Because the area of the square is just length times width, 5 times 5. And how many of them do we have? 6. So 25 times 6. So you could have done it that way as well. Yes?
I have a question, because I was going to say that I didn't know if it was instead of finding the volume, could you just find the area of like one face and like now turn of the cube and then multiply by 6?
Yeah, but you were asked for both. So you could do them using the formula or without using the formula. It would be up to you. TJ?
Oh, when did you use to find volume?
Volume of any box is basically length times width times height.
Oh.
Length times width gets you the flat, the height gets you how deep it is. Right. Other questions? Okay, last assignment before the review.
What's the last assignment?